In this video, we will talk about how to find the least common multiple of large numbers. So I have a couple examples for us to work through here. Let's check out the first one. Let's find the least common multiple of 84 and 140. So the easiest way to do this is to perform prime factorization, which is where we break down each number into factors until we're left with only prime values. So for example, 84 is an even number, so we know it can be divided by 2. So we'll break it down into 2, and 84 divided by 2 is 42. Now, 2 is a prime number, so we'll go ahead and underline that. That one's done. But 42 can be broken down a little further. So it's also even, so we know it can be divided by 2 and 21. Now, once again, 2 is a prime number, so we'll go ahead and underline that one. And then 21 can be broken down into 7 and 3, which are both prime as well. So we're done with the prime factorization on 84. Now let's do 140. Well, it's also an even number, so we know we can divide it by 2. So we'll say 140 divided by 2 is 70. 2 is a prime, so we'll underline it. 70 is even, so we can break that down into 2 and 35. 2 is prime, so we'll underline it. And then 35 can be broken down into 7 and 5, which are both prime as well. So we've performed prime factorization on both 84 and 140. The next step is we want to write each of these prime values in exponential notation. So the way that we do that is, if we have a 7 right here, it only occurs one time. So we'll say 7 to the first. Notice that the 3 only occurs one time as well, so we'll write 3 to the first. But the 2 occurs twice, so we can say 2 squared. And now over here we have a 7 again, it only occurs one time, so we'll say 7 to the first. 5 only occurs once as well, so we'll say 5 to the first. And then once again 2 occurs twice, so we'll say 2 squared. So to find the least common multiple, we simply identify each unique value and we choose the highest exponent. So for example, here's a 7 to the first and here's a 7 to the first. So they're both equal, so we can just choose either one, but only choose one. So we'll say the LCM is 7 to the first times, notice that there's only one 3, so we'll choose this one, 3 to the first. And now we have a 2 squared, and over here we also have a 2 squared. So they're both equal, so we can choose either one, but only choose one. So we'll say 2 squared times 2 squared. And then lastly, we have this 5 to the first. There's only one 5, so we'll just choose this one, 5 to the first. So the least common multiple will be equal to 7 to the first times 3 to the first times 2 squared times 5. So 7 times 3, that's 21. 2 squared is 4, so 4 times 5, these two terms are 20. So 21 times 20 will be our final answer, and that turns out to be 420. So the least common multiple between 84 and 140 is 420. All right, let's try one more example. Let's find the least common multiple of 106 and 162. So once again, we'll perform prime factorization on both of these values. So 106, that's an even number, so we know we can divide it by 2. 106 divided by 2 turns out to be 53. And it turns out that 53 is actually a prime number. So we're actually done with our prime factorization right here. 53 is prime and 2 is prime. So let's move on to 162. It's an even number, so we know we can divide by 2. 162 divided by 2 turns out to be 81. 2 is a prime, so we'll go ahead and underline that. Next, we can break down 81 a little further, so that is 9 times 9. Each of these can be broken down further into 3 times 3 and 3 times 3. So 3 is prime, so we'll go ahead and underline each of these 3's. Okay, so just like the previous example, we'll write these in exponential notation. So the 53 occurs one time, so we'll write that as 53 to the first. And the 2 only occurs one time as well, so we'll write that as 2 to the first. Now over here we have 3, and it occurs 4 times, so we'll write this as 3 to the fourth. And then we have a 2 right here, and it only occurs once, so we'll write that as 2 to the first. So once again, we want to identify each unique value and pick the one with the highest exponent. So here we have 53 to the first. It's the only 53 we have, so it must be included. So we'll say the LCM is 53 to the first. Now here we have a 2 to the first, and over here we have a 2 to the first. They have the same exponent, so we can choose either one since they're equal. But we can only choose one, so we'll say times 2 to the first. And then we have 3. There's only one 3 that occurs, so we must use this one as well, 3 to the fourth. So the least common multiple is going to be 53 times 2, that's 106. 3 to the 4th, that is 81. So the least common multiple is 106 times 81, and that turns out to be 8,586. So the least common multiple between 106 and 162 is 8,586.